Thanks, everyone. Thanks, Mike, for inviting me. For those of you that don't know me, I'm Dr. Stephen Park. I'm an ear, nose, and throat, head and neck surgeon. I practice here in Manhattan. And my passion is helping people with their sleep breathing problems, namely sleep apnea, snoring, upper airway resistance syndrome. And over the years, as I've talked to many different groups and doctors and other professionals, questions about the nose are probably one of the most common issues that come up. Because first of all, if your nose is stuffy, nothing's going to work properly, including CPAP machines, whether it's dental devices. But just having stuffy noses is such a common condition when you have sleep apnea. By definition, you're going to have some degree of it. And so tonight's talk is I'm going to describe the various reasons why we have stuffy noses, and what you can do about it. Okay. So, why do you have to breathe through your nose? I mean, can someone tell me why is it important to breathe through your nose? Filtering process, yes. Okay. Anyone else?
What would be your alternative?
Humidity, yeah.
What would be your alternative? Alpha.
Right, but what are the advantages of breathing through your nose versus your mouth?
I'm sorry?
What are the advantages of breathing through your nose versus breathing through your mouth?
Your mouth will dry out real quick.
Okay.
Right?
Absolutely. So the nose has a number of different functions. The nose is actually an organ. It warms, humidifies, filters, because it has a mucus blanket. It also smooths the flow of air, so instead of having turbulent air, it kind of goes in smoothly. So it prepares the air before it goes into your lungs. Now, the sinuses, that's a different topic in itself, but the sinuses also act as a resonator box to lighten your skull, and also it helps to protect your eye socket and your brain. It also acts to basically help to improve your vocal quality when you sing or talk. But if your nose is stuffy for whatever reason, then things downstream don't work well. So when the air can't reach your lungs, then you're in trouble, and that's what sleep apnea is. Now, with sleep apnea, it's not just your nose, but it also includes your throat and your tongue, and we can talk about that some other time. But for tonight, we're going to talk about the nose. Now, there are many, many different reasons for nasal congestion. We're going to get into each of these areas, and how nasal congestion relates to sleep apnea, and this is maybe a surprising thought for you, but sleep apnea can also cause nasal congestion, and nasal congestion can aggravate sleep apnea, so it's like a vicious cycle. We'll talk about some of the physiologic principles. We're going to talk about many of the initial conservative ways of treating nasal congestion. Then we'll move up the steps into medical therapy and then surgical therapy. Okay, so we talked about why it's important to breathe through the nose. It warms, humidifies, filters, and smooths the air. It's also involved with smell and taste. So obviously you have smell receptors in your nose. That's also connected to the taste receptors in your tongue. And you need to be able to smell to taste. So when your nose gets stuffy, things don't taste well, right? Now, the other thing is that the nose brings air from your nose into your lungs, so it brings oxygen into your lungs. But one thing that most people don't know about is the fact that there's another gas that's made in the nose and sinuses called nitric oxide. And this is the same molecule that they describe in blood vessels, has to do with heart disease, helps to dilate the blood vessels. But in the nose, what happens is the nose and the sinus mucous membranes make nitric oxide, and it serves two major functions. Number one, it's antimicrobial, so it kills bacteria, funguses, germs, viruses. So it helps to sterilize the nose and your lungs. And number two, more importantly, when you breathe nitric oxide into your lungs, it increases oxygen uptake by 10 to 20%. So think about that. If you're not breathing through your nose, you're missing out. Think about what you're missing out on. Okay. So we're going to go into some of the anatomy here. So first I'm going to describe what the septum is. The nasal septum is the midline partition of your nose. So it goes right down the middle of your nose, starting from your tip of your nose, goes all the way back to about here. And so this is the tip of the nose right here, and it goes all the way back. It stops right here just before the nasopharynx, before it dives down into your throat. So this is the midline structure. The middle part is made of cartilage, and the upper back and the bottom back parts are made of plates of bone. And so if you look straight on, normally it's a straight, flat piece of bone and cartilage, but if it's curved in any way, that's what a deviated septum is, and we'll get into why that happens a little bit later. Now, along the side walls of the nose, you have the septum right in the middle, and on the side walls, you have what are called the turbinates. Turbinates are like wings. So this is the nostril over here. And if you look through the nose, what you see is these little wing-like structures. And sometimes when you can see the turbinates, if they're really enlarged, people will say it's a polyp, but it's really not. It's just a very large turbinate. And the turbinates, what they do is, like what wings do, it helps to smooth the air as it goes through. And the turbinates are bony structures on the inside, and it's covered by very vascular erectile tissue, and then on top of that is a mucous membrane layer. So the turbinates can actually swell up pretty significantly. It's actually the same kind of vascular tissue as in the penis. It swells up significantly. And then when it swells up, the blood flow just kind of squeezes out all the mucus. And that's why when your nose is stuffy, you also have extra mucus. Here's an interesting factoid. Did you know that you drink about 2 pints of mucus every day? Yes. So imagine if you had a cold or an allergy attack, it's even double or triple that. Okay. So what causes nasal congestion? This is a long list of things. Almost anything can cause nasal congestion. So it goes from allergies, having large turbinates for whatever reason, having a deviated septum, if you have infections. There's a condition called non-allergic rhinitis. This is more of a neurologic condition that's very commonly seen in people with sleep apnea. If your nostrils are very flimsy, that also adds to your nasal congestion problem. If you have polyps, large adenoids, and lastly, small jaws. Now, how many people thought, well, when I said small jaws, like, did you make the connection? Why would you have nasal congestion if you have small jaws? Okay, it's a trick question. Okay, so
What's the answer?
I'm going to explain. So the reason why modern people are susceptible to sleep apnea is the basic premise is that our jaws are much more narrow than they used to be. It's thought that ultimately speech and language development was detrimental to humans. What happened was that the voice box dropped lower behind the tongue, so below the tongue, whereas in animals you see that the voice box is behind the tongue, so the tongue can't fall back. So when the voice box descended, that allowed for complex speech and language, which was beneficial in many ways, but it's also detrimental. And this is why only humans have all these various breathing and swallowing problems that animals don't have. Now, we did fine up until a couple hundred years ago, and then we messed everything up by changing our diets radically. So we went from eating off the land, eating organically, ripping, chewing, shredding, and grinding, and now we're eating all these soft, mushy foods with no nutritional value. So what's happening is that if you compare human jaws and dental structures now compared to 100 years ago, everything is much more crowded. So yeah, this is why many young people need braces. It's a given that people will need braces as they go through adolescence. If you ride the subways, just take a look at the younger people and the older generation. You'll see that the young people have these narrow jaws, narrow faces. Now, the smaller the jaws, the smaller the space there is for the tongue to sit in. Okay, so relatively speaking, the tongue may look big, but it's not that the tongue is too big, but the jaw's too small. So what ends up happening is, let me kind of show you with my hands. If you do a cross-section of your hard palate, so your upper jaw, normally the arch should be kind of like this, and the molars are over here. But if it gets crowded, notice what happens. It does this. The sides kind of cave in. So that side-to-side distance is more narrow. So that's what happens is that the hard palate, the roof of your mouth, goes up a little bit like this. So this is what's called a high-arched hard palate. And so notice what happens. The molars cave in, the roof of your mouth goes up. And then notice how the roof of your mouth is the floor of your nose, right? It's a junction between your nose and your nasal cavity. The septum normally sits like this. So notice what happens when the roof of your mouth goes up. It buckles. Or it can do this, or it can go into an S shape. So you get these weird contortions that usually folds in the horizontal plane. So people think that deviated septums were due to nasal trauma. So if you got punched in the nose, you would think that the septum would curve like this. But most deviated septums are like this, way in the back of the nose.